Hello and welcome to the world of galaxies. We live on planet Earth. Earth is part of the solar system. Sun is a star, but Sun is not the only star we know of. There are about a billion stars in our galaxy, the Milky Way. But Milky Way is not the only galaxy we know of. There are about a billion galaxies in the observable universe. Today, I will take you to the world of galaxies. I will give you a preview of what we know of and what are the mysteries waiting to unravel. First, let us know our full address, our cosmic address. We are part of the solar system. That solar system is part of the Gold Belt. That belt is somewhere here, and this is our place in the Milky Way, our galaxy. Milky Way is part of a local group of galaxies. Those local group of galaxies are part of the Virgo cluster. Virgo cluster is a part of a Lankaia supercluster, and supercluster is part of the observable universe. All the white dots here are galaxies. These are some of the nearby galaxies. All the white spots that you see in each of this image is a star. Most of these stars have planets around them, so there must be a lot of worlds flourishing other than our own on Earth. These images have been taken by a very powerful camera called a telescope. This is from a ground-based telescope. I have personally took the cutout, reduced these images, adjusted the contrast of these images, and these are some of the things that astronomers like me do. They deal with the raw images from the telescope, make it worthy of interpretation, and then we derive results from that. But one thing that can be easily done with these galaxies is that they can be classified according to their structure, according to their shape, according to their morphology. This is the Hubble tuning fork diagram. So either the galaxies are ellipticals, means the stars that are rotating around the center of the galaxy are in various orbits. The orbits are not confined to a plane. So overall the distribution of stars is like that of particles in a football or a rugby ball of different ellipticities. But here on this side, these are spiral or disk galaxies. So here the orbits, the stars are rotating around the center of the galaxy and the orbits are confined to a plane. So the overall distribution of stars is like that of particles on a disk, and these disks also have very beautiful spiral arms. Some of them have bar-like structures in between. And this can easily be done by amateur astronomers. For example, Galaxy Zoo is a citizen science project. So general people see the images and classify the galaxies according to their structure. These are some of the faraway galaxies. There is one concept that is very important to be understood if we want to study astronomy. That is that further away an object is, it is giving us a picture of a younger universe. For example, if a galaxy is billion light years away, 1 billion light years away, so that means that light has taken 1 billion years to reach us. So that means it is giving us a picture of the galaxy, how it was 1 billion years ago. So that is what helps us, that the further away we look into the universe, we are able to see the younger versions of today's galaxies, younger version of the universe, how the objects have grown, how we are seeing the present day galaxies. So here these galaxies are when the universe was half the age it is now. Right now the age of the universe is 13.7 billion years. Billion is 10 raised to power 9. So that is the present age of the universe. This is when the universe was 6 to 7 billion years old. And what we can see, what we grasp, is that the structures are not that well defined. So that means the clear structures that we know now have formed over the years. And this becomes even clearer when we go further away, when we see even younger universe. So this is when the universe was just 2 or 3 billion years old, and you can see that the galaxies were just mere blobs. This is not because of the imaging capability, because the telescopes, the instruments, they try to keep up in terms of resolution and depth. We are seeing them as blobs because they were blobs. They didn't have well defined structure, and that has been achieved over the years. So here, this will explain you the picture very beautifully. These are the snapshots taken of galaxies in various years. So right now, today, it is 14 billion years old. That is the age of the universe. And today we see these beautiful structures. We see ellipticals, we see spiral galaxies. When the universe had just formed, means 2 billion years after that, then the galaxies were like this. Then they grew in mass, they grew in size. Many things remain debatable, but at least this is settled. This is known to all astronomers, that the galaxies have grown in mass, grown in size, and they have transformed their shape, settled into the beautiful structures that we see now. So the research in astronomy in galaxies is about understanding the physical processes that have led to this growth, that have been involved in this transformation, in this growth in mass, size, and transformation of structure. The tools in the hands of astronomers are telescopes. As the telescopes become better and better, advanced and more advanced, we are able to see further and further into the universe. The Hubble Space Telescope came in the 1990s, and that was the first time we were able to see the universe when it was half the age it is now. We were able to see the galaxies that were just 7 or 8 billion years old, and then it got commissioned. It got new and new better instruments. For example, 2010 it got a wide field camera 3 that helped us see the faraway galaxies in the optical visible range, in which our eyes can see. That was the first time in 2010. So it is very lately. And James Webb Space Telescope is working right now. It's a 6,000 crore project. And why has the humanity spent so much of time, energy, and resources into building it? Is because we want to see further and further into the beginning of the universe. We want to see when the first galaxies, first stars formed, and how we have reached where we have reached. So this is a very hot field where thousands of people work in terms of designing instruments, in terms of analyzing the data, in terms of having an analytical understanding of it, theoretical understanding, observational understanding. So a lot of people are involved, and they are trying to get to the base of it. We can stop the video here, and if you liked it and you want to hear more about the cosmos, about the mystery of the galaxies, about how we try to unravel them, then you can write that in the comment section, and we will come up with newer and newer videos to do that. For example, we will talk about how the telescopes, the better telescopes, help us resolve better in terms of the inner components of the galaxies. How viewing the galaxy in different wavelengths, in optical, in infrared, X-rays, help us understand what are the various components, where they are distributed. For example, where is the molecular gas, the stars, the atomic gas, the ionized gas, that forms the various components of the galaxy. Then how all these components are connected to each other, what are the processes that connect them, what is the cycle that goes inside the galaxies. Then the intriguing presence of the elusive dark matter. What is this dark matter? How do we know of it, and why do we know so little of it? Then what is the distribution of stars in a Milky Way like galaxy? Then what is the life cycle of stars, the end stages including the black hole? Then what is the concept of cosmological redshift? How do we know that we live in an expanding universe, the ever expanding universe? How do we know of it? Then what can we decipher from the spectrum that we receive from galaxies, the emission spectrum, the absorption spectrum, how it tells about the various constituents of the galaxy? Then what is the mass composition of the universe? What is dark energy, dark matter? Uh, then how all these things are related? Then what are the different distances in standard cosmology? Then other concepts. So all these things we can talk about. You can write in the comment section and we will get back with more exciting and interesting videos. Thank you for watching.